So now that we know that pure substances such as elements and compounds cannot be separated by any sort of physical means, that leaves the point that mixtures can be separated. So let's discuss the 4 different ways that you can separate mixtures. The first one is called decantation. Sounds kind of weird, but basically what it is to pour things off. For example, if you decant, like say you well, the best example I'm thinking of off the top of my head is like gravy on Thanksgiving. Sometimes you have the oily stuff on the top, and then you have the actual gravy below it. There are certain type of decanters that you could serve where we get the gravy on the bottom, kind of talking about the browned liquid gravy, versus the oil on top. It's basically just to pour it in a very special way where you can either pour off the top or pour off the bottom, but it's a really rather simple physical means of separating mixtures. You may have to have a special type of glassware or device to do it, but that's what decantation is, to pour off a layer without pouring off both at the same time. Filtration is basically, well, I think you guys know what it is. There's 2 different types that we use in chemistry. One's called gravity filtration. It's kind of like making coffee. You basically have a filter. You pour your mixture into the filter, and some things come through and some don't. It's quite simple. And again, the force that it's doing it is gravity. It could be a little slow, but it will work. And then what you get, again, is a separation. Some things, the larger things caught in the filter, the smaller things, like the liquid, will go through into your container. The other type that we use sometimes is called vacuum filtration. It's basically the same thing. It's just kind of sped up through the process of a negative pressure or suction. So what we sometimes use is, you could see here in the image, is that we use a sink over here to draw water out. By pulling water through, we create a negative pressure because the water rushing by will draw the liquid from the filter or through the filter into the bottom container, which is called the filtrate. It's just another way to do it. Like I said, they're both filters. It's just one is a little quicker than the other with the help of some sort of running water or something like that. The third one is called distillation. Distillation, again, is sounds complicated, but it's actually not that hard. Well, I say that. Basically what you do, if you look at the image on the left, you have a liquid, which is the distilling flask. You heat that up till it boils. So it's going to vaporize, go into the gaseous state, and rise because, of course, it's less density. So it will rise up. Then as it goes through, it'll go through the condenser, which is that tube going sideways. In the condenser, you have the tube, which the distillate will go through. And then on the outside of that condenser, you have cold water. So you have water going in and out of this condenser, which is cold. Because it is cold, it will cause that gaseous vapor to condense. Hence, it's called a condenser. It will condense back into the liquid state. It will run by gravity down into the receiving flask, which is going to give you the distillate. That will separate a mixture, a liquid mixture. Again, really just the things that will volatilize or vaporize will go up through the condenser, back into the liquid state, into the receiving flask. Everything that does not evaporate will be still left in the distilling flask. This is also a way that some liquors are made, is a distillation process. This is basically what they do, just on a large commercial scale. We could do this again to separate things. If you boil everything, then it could, and if you get it really hot, it may all eventually go over. So again, you have to be careful, which is why you have the thermometer, to measure the temperature that would be ideal to separate one component from the mixture without getting everything from the mixture. So that's called distillation. The last one, again, is called chromatography. This is what I did for my master's in biochemistry. I did a lot of chromatography. So we have it's basically a way to separate a mixture using what's called a mobile phase and a stationary phase. The stationary phase, well, is not going to move. The mobile phase is going to carry whatever is dissolved or whatever is carried by the mobile phase and separated along the stationary phase. There's several different types. There's paper, gas, thin layer, liquid, and many others types that have been developed in the last couple decades. The most common and easy to explain is paper chromatography. So basically what you have here on the left side is you have the paper. That would represent the stationary phase. You have the liquid at the bottom of the flask, which is going to represent the mobile phase. The mobile phase, the liquid, will, through the capillary action, will move up the paper all by itself against gravity. It requires no force, no suction, no nothing. It's just going to travel up the stationary phase, in effect becoming the mobile phase. Now what you have right here is some sort of dark dot. That could be ink from a pen, that could be chlorophylls from a plant, it could be all sorts of different things. Again, this is kind of the simple example, this is not the most technical stuff. But as the mobile phase, the solvent, the liquid, travels up the paper, the stationary phase, it will carry with it whatever is dissolved into that mobile phase. And as doing so, will separate the mixture vertically as it travels up. So as you look at the image on the right, you have several different colors that have separated, and that's where the word chromatography comes from, because chroma refers to colors. So this process was discovered because it would separate colors. Hence, we call it all chromatography. Again, that's just another way of physically separating a mixture. This I found kind of interesting, but let's go ahead and cover it. It says that the naturally occurring elements on Earth, basically there are 118 elements in the universe. We on Earth have 1 through 92 with the exception of 2, which is 43 and 61. 43 is technetium. No, I thought we had technetium on Earth. And 61, which is PM. I don't remember what PM is. I don't have that one memorized. It's way the heck down here. Those are hard to memorize. Anyway, with the exception of those two, those are all naturally occurring on Earth. Now, really, there's only a few that are very, very common, very predominant, and the vast rest of those 92 are extremely rare. Oops. All right, so the class...
I'm not sure I understand.
Sorry, that was Siri chiming in. So there's two things on your notes. One is the difference between an element and a compound. If you look on the left side of this image, you'll notice that an element and compound are both pure substances. So that's what they have in common. They are both pure substances. If you have pure sugar, that's a compound, but it is pure. It is just sugar. If you have, I don't know, like in this example, helium, well, that's just helium. And there's the example of the Hindenburg, or excuse me, the Goodyear blimp. We don't use hydrogen anymore because of the Hindenburg disaster. How they are different, of course, is an element is all one type of atom. A compound, of course, is all of one type of, compound is all of one type of compound. It's pure, but it's made of multiple elements bonded together. So I'll let you guys draw this. Again, you don't need to get to drawing the T or the ocean. Don't be ridiculous. Just draw the top portion, please, in your notes. I also wanted to point out real quick that if you look at the bottom left 3 images, we earlier had skipped a part about how solids, liquids, and gases look at the atomic level. And if you could see, to go through it very quickly, on the left you have gases. Notice the particles are very far apart, and you can see kind of, it tries to show that they're moving very, very quickly. In the second one we have water. Notice again, they're close, but they're not super close. And you can kind of see that they're moving a little bit, or there's some in front of the other ones, and so on. What we have here is wet sand. Wet sand is, of course, we have the water above it, and then the solid below it. So notice the solid, they're very, very, very close, which again gives it, well, what we call solid. And then above that is the water, and notice again they're close, but not as close. So if you guys want to go back to the previous part of the packet and draw on those 3 images, obviously don't make it this complicated, but just kind of get an idea. You could use circles or whatever, I don't care, but that will give you a good idea. So that again is the separation techniques of mixtures.